Today we are working on special parallelograms. So first off, we're looking at rectangles. So remember that a rectangle is a quadrilateral that has 4 right angles. And those 4 right angles are in the corners of your rectangle. And again, a rectangle is a special kind of parallelogram. So it has all of the properties of a parallelogram. So remember the properties of parallelogram. We have 2 sets of opposite sides parallel, which makes it a parallelogram. Opposite sides being congruent. Opposite angles that are congruent. Same side interior angles that are supplementary. Which remember, supplementary means that they add to equal 180 degrees. And that the diagonals bisect each other. Please remember that bisects means cuts in half. Does not relate to the angles. Diagonals are only cutting the length of that diagonal in half. Then our properties that are specific to a rectangle. First off is the definition of a rectangle, that it has 4 right angles at the corners. And please remember that these are only at the corners. And the other one is that our diagonals are congruent. When we have a rectangle. So we have AC being congruent to BC. So AC is congruent to BD because our diagonals are congruent. Next up, the rectangular gate has a diagonal brace, like it's shown. We want to find each length. We're looking for HJ first. So HJ is this length. Remember that our opposite sides are congruent, so it is equal to 48 inches. Then next up, we're looking for HK. So we've got HK here. And we know LJ is 30.8, which means that GL is also 30.8 because our diagonal bisects each other. And our diagonals on a rectangle are congruent, so 30.8 times 2. And that gets us 61.6 inches. Next up, we're looking at a rhombus. And remember, our definition for a rhombus is that it has 4 congruent sides. And again, it is a special kind of parallelogram. So again, it still has all of the properties of parallelogram. So it still has opposite sides that are parallel, opposite sides that are congruent, opposite angles that are congruent, same side interior angles that are supplementary, and diagonals that bisect each other. It does have a few extra properties of its own. The first one is the definition, and that it has 4 congruent sides. So on this picture over here, segment AB is congruent to segment BC. It's also congruent to segment CD, which is also congruent to segment AD, because all of the sides are congruent. The other thing we know is that the diagonals are perpendicular, which means that they make right angles where they intersect. So in our picture up here, segment AC is perpendicular to segment BD. So when you have a rhombus and you see the diagonals right there in the middle, put your right angles, because all 4 of those are right angles. The other property we know about rhombus is that our diagonals bisect opposite angles. So in this picture, that means that angle 1, 2, 5, and 6 are all congruent to each other. And angle 3, angle 4, angle 7, and angle 8 are all congruent to each other. Our next example, we have a rhombus here. And remember what I said, in the center where the diagonals intersect, put your right angles. So we know that 2y plus 10 equals 90. So we can solve for y like that. Subtract 10 from both sides. So 2y equals 80. Divide by 2. So y equals 40. So now we can find angle TSV by substituting. So 40 plus 2 equals 42 degrees. And that is this angle here is 42 degrees. But we are looking for angle WSR, which is this angle. WSR, remember that this angle is getting cut in half, means that angle WSR is the same as angle TSW or TSV. So it is also 42 degrees. Next up, we're looking at a square. And a square is a quadrilateral. Again, this time it has 4 right angles and 4 congruent sides, which means that it is both a rectangle and a rhombus, as well as a parallelogram. So it's got the properties of a rectangle, a rhombus, and a parallelogram. So that means that it has opposite sides that are parallel, opposite sides that are congruent, opposite angles that are congruent, diagonals that bisect each other, and same side interior angles that are supplementary because it's a parallelogram. It has 4 right angles in the corner and diagonals that are congruent because it's a rectangle. It has 4 congruent sides, diagonals that are perpendicular, and diagonals that bisect the opposite angles because it's a rectangle. So it's got all the properties we've talked about today. So in our figures here, we want to label the missing side lengths. So we need our side lengths. We know that all 4 of the sides are 8 centimeters because our sides are all congruent, which means we need to find our diagonals. Now remember that we have 45, 45, 90 triangles. So our diagonal is 8 square root of 2 centimeters. Which means that half of the diagonal is 4 square root of 2 centimeters. Then when we look at our angles, we know that the corners themselves have to add up to 90 degrees, and that each of the smaller angles is 45 degrees because the diagonals bisect the opposite angles. And we know that the center, each one of these angles is 90 degrees.